Assalamu alaikum. How are you, my dear students? I wish all of you are well. This is Ami sir in front of you. I am also well. This is my very first class, video class with you. At first, take some uh, picture. Take some picture from my computer screen. That is, chemistry is fun. Chemistry is fun. Do you think chemistry is only fun? What do you think? Actually, no. Chemistry is not only fun. We can learn so many things from chemistry. How? Okay, listen. This F, fun. This F means the symbol of fluorine. U means symbol of uranium. N, this N means the symbol of nitrogen. So we can learn, we can read so many things from chemistry. Okay, thank you. Then here you observe a picture of modern periodic table. You know there are 118 elements, from 1 to 118 elements. So we have to learn most of them. Most of them, they are situated in which group, which period, their atomic number, atomic mass, etc. and etc. Okay. So do you think is it possible to learn 118 elements in class 9? No, actually no. This is not possible. That's why we have to learn at least 1 to 30 elements and their electronic configuration. That's why my today's topic is electronic configuration, and this electronic configuration is in chapter number 4. This electronic configuration is in chapter number 4. So observe my next slide. Here how can we write electronic configuration? This is the procedure. You can see the sequence of electronic configuration. Okay, 1s, 2s, 2p. So what do you think about 1s, 2s, 2p? Actually, when you are in class 8, suppose for sodium, you wrote the electronic configuration like this way, 281. But in class 9 and in senior section, you have to learn in different way, by this way: 1s, then 2s, then 2p, then 3s, then 3p, then 4s, 3d, 4p, 5s. By this way you have to understand how can we write the electronic configuration. So you can ask me, sir, how can I write this procedure? Okay, listen to me. How can you write the procedure? Suppose at first you write 1s, then 2s, as usual 3s, 4s, 5s, 6s, 7s. Then p. 1p is not possible, you know this. 1p, where we write 2p orbital, little bit lower part of 2s. This is 2p, then 3p, then 4p, 5p, 6p, then 3d, 4d, 5d, 4f. You know there are 4 orbitals, s, p, d and f orbitals. You can write by this way. At first electron will go to 1s, then 2s, then 2p, 3s, then 3p, 3s, 3d, 4p, 5s. By next this sequence, you can write the electronic configuration. Okay, and you know the maximum electronic configuration, maximum electron capacity of orbitals or orbitals. You know the maximum electron capacity of different orbital is, for s orbital is 2, for p orbital is 6, d orbital is 10, f orbital is 14. S orbital maximum electron capacity, so maximum 2 electrons can stay in s orbital, maximum 6 electron in p orbital, maximum 10 electron in d orbital, maximum 14 electrons can stay in f orbital. So 1s, so 2 electron, maximum 2 electrons will go to 1s orbital, then 2s 2 electron, 2p 6 electron. By this way you can write the electronic configuration. Okay, then you can learn how can you write the electronic configuration of different elements. Okay suppose nitrogen, this nitrogen comes from fun. Okay, nitrogen atomic number is 7, so 1s2, 2s2, then 2p, 2, 2, 4, remaining 3 electrons, then 2p3, then 3 electrons will go to p orbital, because we have in total 7 electrons, so 2 electrons will go to 1s orbital, 2 electrons in 2s orbital, 3 electrons in 2p orbital. Okay students, here you see the electronic configuration of nitrogen. So you can observe the orbital diagram of nitrogen in that corner of board. Observe the orbital diagram of nitrogen. Here the electrons are distributed in different orbit by using this way, so you can understand by orbital diagram. Okay dear students, now we are talking about the electronic configuration of fluorine. So you know the atomic number of fluorine is 9, so electronic configuration is 1s, 2s, then 2p. So you know 2 electrons will go to 1s orbital, 2, then 2 electrons will go to 2s orbital, then 4, 2 plus 2, that means 4. So we have in total 9 electrons, 4 electrons already it is in 1s orbital and 2s orbital, that means remaining 5 electrons, 9 minus 4, that means 5. These 5 electrons will go to this 2p orbital. Similar way at that corner of board you can observe the orbital diagram of fluorine. So you can observe this orbital diagram also. Okay student, you can observe in first orbit only 2 electrons, and in last orbit, that means second orbit, and there are 7 electrons. For fluorine atom. And for uranium, atomic number of uranium is 92. So it has 92 number of electrons. So its electronic configuration is huge. I already told you that to write the electronic configuration of uranium is tough. You will learn it in your next theory class. But in that corner of board, I already showed the picture orbital diagram of uranium. Or this is the orbital diagram of uranium atom, whose atomic number is 92. Okay, so your homework is given to you, that is write the electronic configuration of atomic number 1 to 20. Your homework is write the electronic configuration of different elements whose atomic number is from 1 to 20. Okay, thank you very much dear students. Inshallah, see you in my next class. And at last, I would like to thank all my teachers, all facilitators and coordinators, and especially to our director madam. Okay, thank you very much. Assalamu alaikum.